Good morning and welcome to our webinar, How to Develop WirelessHART Devices. This is going to be a great session today. I'm really excited about it. We have with us today Robert Asamidi, who is the CEO and co-founder of Centero. Centero is a developer of, is what we call a development service partner here at FieldComm Group. Remember, but their focus happens to be on providing and developing products for other member companies. Centero's area of expertise happens to be in WirelessHART and wireless devices in general. They've been at it for about a decade, and a lot of the products that you might see in our registered product catalog for WirelessHART devices, although they don't have the Centero name associated with them, they have actually been developed by Centero. So Robert's going to speak a little bit about how we go about doing, how you go about deciding how to develop and actually implementing a development process for WirelessHART devices. And it's our hope that you find this extremely informative. In the a couple of housekeeping issues, as I mentioned in the chat session, we're having a couple of issues with technical issues. You'll see I'm on a green screen. We couldn't quite get the background to work. And some of you, depending on the systems you're using, may have an issue seeing the bottom of the slides. But we'll work through that, and we'll try and fix that during post-production. And we hope you enjoy the webinar. So without further ado, I'm going to turn it over to Robert. He can start walking through his presentation and maybe give a brief introduction about himself and Centero, and we should take maybe 30-40 minutes today, and we're leaving about 10 minutes for questions at the end of it. So thanks again for joining us.
Thank you, Paul. Thank you for the introduction, and thank you everyone for joining the webinar, and also thank you for your interest in developing a WirelessHART field device. So before we get started, this is a quick glance at the agenda. First of all, we're going to go over a fundamental question. Why choose WirelessHART over other IoT or industrial IoT technologies available today? Then we're going to go through the actual device development process, and we're going to take a step-by-step approach and try to highlight and describe each step in the process. We will go through the FieldComm Group registration process, which is a very important facet of developing a WirelessHART device. And then we're also going to introduce a couple of products that Centero offers. To be more specific, the WirelessHART Wireless Module, as well as the WirelessHART Rapid Development Kit. And last but not least, we will have, as Paul mentioned, we will have a short Q&A session. So please feel free to post your questions in the chat window, and we will address these at the end of the webinar. Well, I think Paul already did a pretty good job of introducing me. I'm the co-founder and CEO of Centero. We've been around for about 10 years now, and we are focused on industrial IoT products, solutions, and technologies. So let's start with a few WirelessHART facts. So as probably most of you know, WirelessHART was specifically architected for industrial process automation. And it's really architected with extreme reliability in mind, as well as ensuring that data packets are delivered with guaranteed latencies. As probably most of you know, deploying wireless field instruments in refineries, petrochemical plants, mining, these are fairly harsh environments from both, primarily when it comes to RF wireless propagation, lots of metal, pipe jungles. So reliability is of paramount importance. And we'll touch on a few of the mechanisms that were included in the WirelessHART technology and standards in order to ensure maximum reliability. It's also been rubber stamped under IEC 62591 as an international standard. It was approved in 2009, in January 2009 to be more precise. Also built on the solid foundation of HART. which, as probably most of you know, has been widely deployed since 1986. HART is a very well understood, widely deployed technology. Most end users are fairly familiar with, or if not very familiar with HART. Let's see. Also, at this point, there's a medley of HART and WirelessHART instruments that are deployed in 50,000 plus networks, and also an installed base of about 50 million plus devices. So that's quite an ecosystem of instruments deployed out there. Another quick fact is, and this is very important to understand, that HART and WirelessHART share the same application layer. Now, why is that important? It's important because it's important for both folks like yourself, like field instrument vendors that are developing WirelessHART instrument, because it will make for a seamless transition from the wired HART instrument that you currently have developed or offer. But it's also important to end users, since they are probably already very familiar with the HART application layer concepts and mechanisms. And just a quick fact related to the FieldComm Group. The FieldComm Group is tasked with defining and maintaining the specification, as well as a QA/QC program, which ensures interoperability to a registration program. And last but not least, the FieldComm Group is also tasked with training or providing workshops, webinars such as this one, and also with providing support during the development and registration process. Now, why choose WirelessHART? Obviously, if you are attending this webinar, you have an interest in WirelessHART, and it's probably a fair assumption that you have researched various different industrial IoT technologies at this point. I would like to highlight some of the benefits of choosing WirelessHART over other existing IIoT technologies that are widely deployed out there at this point. So first of all, reliability. As mentioned a bit earlier during this webinar, the reliability is up close to 100%. A lot of effort went into ensuring this high reliability, which is of paramount importance in process automation, monitoring, and control. And how do we ensure or guarantee this reliability? Is by a superimposition of various different mechanisms that are included in the protocol itself. Path diversity, more commonly known as mesh routing, ensures that there are always multiple paths that a data packet can travel when being reported to the gateway or from the gateway to an L device. Time diversity, everything happens in very well, clearly defined 10 millisecond time slots. And frequency diversity. So we're continuously changing frequency channels while the communications are taking place. Now, once you superimpose these three mechanisms, this is how we ensure this very high reliability. Interoperability. At this point, if you go check the FieldComm website, you'll see that there are 27 registered field instruments or devices from 15 different manufacturers. And all of these utilize HART data structures and are also guaranteed to interoperate with existing control systems. That is actually part of the FieldComm registration process that we will go into more detail a bit later in the webinar. Security. Everybody's worried about security these days. How do we secure data in WirelessHART devices? Well, first of all security protocols are mandatory. And we use a two-layered security construct, a hop-by-hop authentication mechanism that we use at the data link layer that terminates in the gateway, and then in the access point, and then a transport layer authentication and encryption scheme. So at the transport layer, we both authenticate and encrypt every data packet. And this is what we typically refer to as end-to-end security between the actual field device and the gateway. Moving right along, scalability. WirelessHART networks typically scale to hundreds of devices per network. All devices are organized in mesh networks. Multi-hop data communications are supported, so there's no need for gateway line of sight. And last but not least, WirelessHART is a deterministic technology, meaning that there is a sophisticated software process called the network manager, the network and security manager, that runs in every gateway that basically uses fairly sophisticated algorithms to determine in which exact time slot each device should listen, send data, or sleep, as well as the entire frequency hopping scheme and the mesh routing. Full data context. So all the application layer data points have full context. And what do I mean by full context? They include units, timestamps, and health information. What that does is really maximizes the value of the data of the application layer payloads to where it can be used in rich, meaningful analytics. Published by exception. So WirelessHART devices do periodically burst or publish data, and this bursting or publishing mechanism can be configured to only occur when certain process or device conditions have taken place. And compared to polling, where the gateway would continuously request this data, this reduces the energy needed, which is important because pretty much all WirelessHART, if not all WirelessHART devices out there, are battery or harvester powered. So this is a quick reference guide that we put together. I find it very helpful. It gives you a bird's eye view, a snapshot of the entire development and registration process. As you can see, the first step is defining the product, the architecture, and planning the project. The second step is developing a functional prototype. The third step is developing your hardware and firmware. Software system integration, which is really refers to developing a DD or EDD file, followed by the FieldComm Group field device registration process, and last but not least, passing various regulatory compliance and certification tests. Now, it's important to point out that step 5 and 6, namely the FieldComm Group field device registration process and the regulatory compliance and certification process, can happen in parallel. And we will delve a bit deeper into each one of these steps. So let's start with product definition. So first of all, what you want to do is create your functional requirements. Well, just as with any other product development process or effort, it is important to have a clear definition of the requirements. But this assumes a basic understanding of the features and mechanisms that are present or offered by the WirelessHART protocol and technology. As the first decision the developer is faced with is choosing the device type. As far as field devices are concerned, WirelessHART offers two options. Option 1, you can develop a field device or a field instrument, or option 2, you can develop a WirelessHART adapter, to where you would connect the adapter to an existing wired HART instrument and really enable it wirelessly to where it becomes part of the WirelessHART ecosystem. Next, you would define the application layer functionality. And what that means is you would define what the inputs and outputs of the field device are, how it will be configured, commissioned, calibrated, what type of standard HART commands you would use to configure and operate the device, and also the set of alarms that the field device will offer. Moving right along, the next decision you'll be faced with is choosing your sensor or actuators, because in WirelessHART you can do, well, we support both monitoring and control, but that's really dependent on the applications that you are, or the use case your field device or instrument will be engaged in. just your typical, we have your traditional process automation instrumentation such as pressure, temperature, flow. But more recently, we've seen more exotic use cases surface, and they have gained quite a bit of market traction, such as steam trap monitoring, vibration monitoring used for predictive maintenance. And in the last 2 or 3 years, we've really seen an upsurge in safety, WirelessHART safety or instrumentation, such as gas detectors, flame detectors, and so on and so forth. The next decision you will be faced with is choosing your power source. As I mentioned earlier, the vast majority, if not all, WirelessHART instruments are battery powered or harvester powered. And then last but not least, operation hazardous areas. You would have to choose or define the requirements in terms of operating in a HAZLOC location. Will this instrument need to be ATEX compliant or certified, or a class 1 div 1 compliant and certified, the areas they will operate in, and so on and so forth. Let's move right along. It is important to understand the anatomy of the internal anatomy of field device. So every WirelessHART field instrument is really structured based on this architecture. So we have a wireless module that runs the WirelessHART communication stack, and that includes all the networking, meshing, security, the physical layer, as well as a set of the HART commands. Also, the WirelessHART specific commands are also implemented by the wireless module, and an application processor. The application processor connects with the wireless module via serial interface and runs the application, the HART command application layer, as well as connects to and manages the sensor actuators that the field instrument utilizes to monitor or control the process. And down at the bottom, we have the FSK modem. So each WirelessHART instrument has to include a HART FSK wired modem. Now, this is what is commonly referred to as the maintenance port, and it's used for provisioning, commissioning, and also for issuing commands via the FSK physical layer. In most architectures out there, as you can see, there are 2 arrows showing, well, giving you 2 options to connect the FSK modem to the application processor or to the wireless module. I would like to point out that in most architecture, it is connected to the application processor, and it is the application processor that manages and drives the maintenance port. Now, this is just a bit more information in terms of the responsibilities of the 2 entities. So the application processor implements the HART application layer. It connects and manages the sensors and actuators. And then it also bursts or publishes the data to the gateway. As mentioned earlier, it manages the maintenance port, and it's typically also in charge of monitoring and managing the battery life of the instrument, and managing the sleep status of the WirelessHART modem. Now, the wireless module itself implements the WirelessHART communication stack. It does comply to IEEE 802.15.4 and operates in 2.4 gigahertz. There's a typo there. It also, as mentioned earlier, includes the meshing, the TDMA mechanisms, which is the time slotting. It's responsible for device security, mesh networking, as well as reporting device health parameters and diagnostics to the gateway. And is also responsible for joining the network and managing the mesh connectivity. Now, I would like to introduce the WirelessHART module that Centero offers. It is the WiHART module. It runs a communication stack compliant to HART 7.6. It includes a reference implementation that includes all the components needed to develop a WirelessHART certified instrument. And we both we boast with having the market lead sensitivity of minus 108 dBm, which when added to the 10 dBm output power that each wireless HART is required to support, results in a 118 dB link budget. It is specifically designed for integration in intrinsically safe instruments, and it has been integrated in several instruments that are intrinsically safe rated and certified, as well as explosion-proof instruments, of course. It does have an onboard front-end module, RF front-end module, which supports selectable RX gain modes. It is designed for real estate constrained products. It's got a tiny footprint, and it has been tested for interoperability with Emerson's, Pepperl & Fuchs, Santero's gateways, as well as a host of other wireless HART gateways. Let's get back to the actual development process itself. The project team. Well, when developing a wireless HART device, you do have to have a multidisciplinary engineering team or teams. And that includes a solid understanding of HART and wireless HART protocols, as well as you need to have a fairly good grasp on RF engineering and some RF expertise in-house. You will have to have a fairly solid, versed hardware and firmware engineering team, a software team that would be in charge of developing the EDD files, DD or EDD files, or any other files that are needed to integrate with a DCS or PCS. And then, of course, you would have to have some expertise as far as certifications are concerned, certifications for hazardous locations, as well as wireless certifications, EMC safety, and so on and so forth. Now, I would like to highlight that the FieldComm Group offers quite a few development and validation tools. And let's start with the HART physical layer test kit. The HART physical layer test kit ensures the physical layer, the FSK physical layer conformance of the maintenance board. And then the FCG also offers the HART test system, and this tests the 420 FSK port of the field devices. The WirelessHART test system, which is a simplified gateway that is used for testing. The Wire Analyst tool. This is a very versatile tool. Is a packet sniffer that sniffs all 16 frequency channels and parses all the data packets to where it's really an invaluable tool when it comes to during the development process, because you are able to monitor the communications, the wireless communications, not only of the field device that you are developing, but also of the entire wireless HART mesh network that the instrument is engaged in. The FDI device package, this is used to develop EDD, DD, and EDD files. And then HART IP clients. These are typically used in the gateway, well, always to connect wireless HART devices via the gateway to various different entities running on the plant network, or software entities running on the plant network. Let's move right along. So the next step would be to develop a functional prototype. It is highly recommended that you start by developing a functional prototype before going into the full-blown development process. The reason being that this allows you to mitigate the risk for while you are climbing the wireless HART learning curve. Also, purchasing or acquiring a wireless HART development kit will definitely accelerate your development process. There are quite a few development kits out there, and they include all the components needed for development, including wireless modules and development boards, a wireless HART gateway that is used to validate the operation of the field device or field instrument you are developing. They typically also include training materials and documentation. And in case of our wireless HART development kit that we offer, that Santero offers, we also include the application processor source code. Now, this application processor source code is It's something that we put a lot of effort into because it truly really accelerates your time to market, reduces your time to market and accelerates your device development process. What does this application processor source code package include? It includes the entire HART application layer framework, including universal, common, and common practice commands. Also, it includes placeholders to where you would just plug in your sensor measurements and control values. And it also allows the mapping of parameter of interest into the 4 dynamic variables that are used in WirelessHART, as well as the bursting mechanism or the publish mechanisms that is used to report these parameters to the gateway. So what is included in our WirelessHART development kit, we include 2 spin development boards, which you see up here to the left. And they include a host of different sensors, temperature, humidity, as well as proximity, a LiDAR sensor, and quite a few sensors that, when you fire the kit up, you'll already see some parameters being reported off the get-go. And then you start fiddling with the application processor to where you would connect your sensor or actuator to the application processor, which is that white Arduino board up there. And you can fairly quickly populate various different data structures with your sensor or actuator values and develop your first functional prototype. The kit also includes a gateway, which is C1D2 or Haslock C1D2 or ATEX rated, and also includes Wi-Fi mesh connectivity. As mentioned earlier, it also includes the application layer source code, which is license-free, meaning that you can, is royalty-free. You can use the application processor in as many instruments as you want. Now, market these instruments, and you will not owe us a penny. And it also includes, the gateway also includes a feature-rich monitoring and control piece of software that allows you to configure and visualize the process values received from the field devices, as well as network and device health diagnostics. It includes a Modbus server, which you can use to connect to various different software entities running on the plant network. And of course, all components of the kit are remotely upgradable over the air, meaning that you can upgrade your wireless modules, the communication stack running on the wireless module, as well as the firmware running on the application processor, as well as all the software entities that run on the gateway. Moving right along, hardware development. This will be the next step in the development process. First of all, you have to choose a battery. And this could be augmented with an energy harvesting solution. We see that a lot in steam trap monitoring, where you have a temperature differential that allows you to use the Peltier effect to harvest that temperature differential. We see that in our vibration monitoring, where you can harvest vibrations, the vibration of the equipment that's being monitored. But anyway, once you select your battery, you would obviously select that battery with the intended battery life in mind. We highly recommend that you run some preliminary analysis and preliminary calculations that ensure that the battery that you select, potentially augmented with the harvesting solution, meets your battery life. And some factors that come into play is how often your instrument bursts data, how many alerts or alarms you're sending, as well as other parameters that are related to the application layer functionality of the field instrument you are developing. The hard maintenance port. Well, the hard maintenance port, as mentioned earlier, each WirelessHART field device needs to include a maintenance port. It is used for provisioning and commissioning. You can commission or provision the instrument without this hard maintenance port. And it ensures that your instrument, end users out in the field will be able to configure or provision or commission your instrument using their existing HART handheld configuration tools. As far as RF considerations are concerned, keep in mind that each WirelessHART instrument needs to output The RF output of a WirelessHART instrument needs to be in the -10 to 10 dBm range. And during the registration process, you will be required to also prove that the wireless module that you are using is 802.15.4 compliant, as well as provide antenna propagation patterns for the antenna that you choose. As far as the enclosure selection is concerned, this is really dependent on your choice of offering an explosion-proof or intrinsically safe instrument. Moving right along, firmware development. That would be the next step in the development process. First thing you have to do when starting your firmware development process, you would contact the FCG, the FieldComm Group, and ask them to assign a manufacturer and device ID. You will be using this during the development process, as well as it's vital for the FieldComm registration process. And once you get started with your firmware development, you'll really be focusing on two facets: integration of the wireless module with the application processor, and then mapping and the sensing and control functionality in the application processor to HART and WirelessHART commands and mechanisms, meaning plugging in your sensor values or your control values into process variables, generating alarms if your instrument is required to do so, and then also configuring the burst mechanism to where you periodically publish these process values. The next step would be to validate your firmware implementation with the WirelessHART gateway. You have it join the WirelessHART gateway and exercise the various different functional aspects of the field instrument you're developing. And then the last step during the firmware development process is typically fine-tuning your battery life. So you have a fully running instrument, it's operational. You're publishing or bursting process values. You're sending alarms and alerts. It's time to fine-tune that application processor that works in conjunction with the wireless module to where it spends the maximum amount of time in sleep mode to where you can maximize your battery life. One thing I would like to point out here is that it does take some fine-tuning, because given that WirelessHART is a mesh technology, your instrument could really be installed on layer 1 to where it communicates directly with the gateway, or it could be installed on layer 3 of the mesh network to where you would have to route data packets on behalf of other instruments. So that is also one aspect that needs to be taken in consideration when optimizing your battery life, ensuring that you are meeting the battery life you're advertising in these different mesh configuration modes, to where you would be a router, you would route on behalf of a bunch of other devices, or you are simply communicating directly with the gateway. Step number 4, software system integration. This is where you would develop a HART device description file. Now do keep in mind, when you go through the FieldComm registration process, you will be required to submit this as part of the registration process. And what does this DD file do? It enables your field instrument to interoperate and integrate with plant network software, with various different distributed control system, PCSs, or diagnostic software, historians, and so on and so forth. So the DD file, what it really does is it models all the capabilities of the field device you are developing. And that includes the commands that you support, the configuration parameters, and the user interface. EDD files, they provide quite a few graphical elements, and they stand apart from your traditional hierarchical text menus that you would see if you just use a DD file. And I would like to point out that the FieldComm Group offers the SDI ID package, which is pretty much all you need to develop and validate a DD file. The FieldComm FCG, the registration process. As a first step in registering a device with the FieldComm Group is you would have to become a FieldComm member. Now the FieldComm Group offers this QA/QC program in order to ensure interoperability, not just between various different field devices, but also between the field device and the host systems that run on the plant network. Why join the FieldComm Group? Well, first of all, you get to shape future industrial IoT technologies, and then another benefit of membership is FieldComm does offer discounted pricing for training, development tools, compliance and testing registration tools if you are a member. And the last but not least, you would gain prioritized access to the FieldComm Group support team. The next step would be for you to purchase the test tools required to test your implementation. It's a complete suite of protocol-specific tools that you'd use to perform the registration test. And the next step 3, would be to perform these registration tests internally. You would run all these tests using the test tools, and you would collect all the test logs and results because these are needed for submission. Well, they will be submitted as part of the registration process, or the registration package. And this is a quick snapshot of the tools that are used to, the tests that are run to ensure compliance of the field instrument. So first of all, you have to confirm the proper operation of your physical layer of the maintenance port. Then you have a suite of data link layer tests, which where you're testing the tokens passing DLL by using the maintenance port. You have your TDMA mesh network layer tests, which are WirelessHART specific commands and functionality. You test universal and common practice commands, and these need to be supported over both the wireless channel and the wired maintenance port. System level tests, these ensure interoperability over the long term, and you can contact the FieldComm Group because they do offer these tests as well. I highly recommend that you run the system level test prior to running, to fully engaging in the registration process. And as I mentioned earlier, one of the requirements for registration is you would have to submit your EDDD file to where because the FieldComm Group does test the EDD file, and ensures that it complies, it's interoperable with various different host systems. Moving right along, the next step you would do is, once you have all your test logs and results and all the supporting documentation put together, you'd submit these to the FieldComm Group along with the DD file and the FDI device package and the wireless compliance documentation. And that includes, the wireless compliance documentation includes any modular certifications that the wireless module has passed, such as FCC, ETSI, basically EMC wireless compliance, as well as you'd have to prove that the module is compliant to the 802.15.4, IEEE 802.15.4 physical layer. Of course, if you purchase a wireless module, the wireless module that runs the communication step has typically passed all these wireless compliance tests. Step 5, you would submit the registration package, place a PO, and submit 2 devices for registration testing. Once the FieldComm Group confirms that all registration tests have successfully passed, your DD file will also be sent out for testing with various different host systems, and your FieldComm device will be registered and listed on the FieldComm Group website, along with the DD file that will be available for download. Step 6, and as I mentioned earlier, this can be done in parallel with the FieldComm registration process. You would have to go through various different certification or compliance testing for the particular hazardous area that you are installing the instrument in. Of course, there's the wireless EMC compliance mentioned earlier. As most wireless modules, WirelessHART wireless modules offer currently in the market, they do already have modular compliance or have obtained certification for operation in different areas of the world, regions of the world, and countries. But you might have to run additional EMC product level compliance test in addition to the modular certification that the wireless module already has. And then some other regulatory compliance and certification tests that you might want to consider are EMC immunity, ESD safety compliance test. To give you some example, EN 301 489, or EMC compliance tested, EMC emissions compliance for EN 55032, ESD compliance for ESD 6100-4-2, immunity and safety. And with that being said, in conclusion, developing a wireless HART does not have to be a daunting endeavor. If you plan the development project, if you purchase a development kit, this will greatly reduce your time to market, and it will minimize the cost and effort involved in developing and registering a wireless HART device. And once you develop a wireless HART device, you will reap the benefits of being part of a widely deployed ecosystem of field instruments, and being able to interoperate with a host, with a really wide gamut of host systems that are currently deployed. And before we move on to the Q&A session, I would like to point out that there are two handouts that are available for download with this webinar. A white paper, which details the entire development and registration process, as well as the content of this webinar. So thank you for your attention, and at this point I will turn it back to Paul for the Q&A session.
Okay, thanks a lot, Robert. I really appreciate that. I've been madly answering questions in the background. So if you are still with us, can you please kind of take a look at what some of the existing questions are and what the answers are, and if you have any more, please post them here. I have one question, Robert, that's going to go immediately to, well, I've got a couple that are going to go to you, but yeah, I guess the first thing that I want to answer is I'd like you to ask is, you know, a lot of our members, particularly our smaller members, are very familiar with developing 4 to 20 milliamp, HART FSK devices, and you kind of mentioned the development requirements you need to have to create a wireless HART device. So this is kind of a softball for quick self-promotion, but why would a company choose a Centero to help develop this? Can you tell us a little bit about your wireless experience overall, and the amount of time that you put into developing your WirelessHART module and things like that? Just give us a little bit of detail there.
Yes. So Centero, we've been developing various different IoT and industrial IoT technologies and products and technologies for under Centero for 10 years, but our team members for close to 20 years now. We've developed different wireless solutions for ranging from smart grids through process automation wireless solutions. Our team is really composed of experts that have been engaged and developing wireless HART technologies for 20 years now. We also took a very active role in various different standardization processes, including various different wireless technologies for process automation. And for the last 4 years, we've invested quite a bit and put a lot of effort into developing a wireless HART development kit that would make it as easy as possible for you to develop a field instrument. And I mentioned earlier the application layer source code that we offer along with well, that's part of the WirelessHART development kit, as well as developing this this kit that includes more than just development tools. It includes a full reference implementation of a device that has already passed FieldComm registration test as part of other field instruments.
Okay, that's fantastic. So I'm sure that somebody's going to ask this question, so I'll just preempt it and ask it myself. So assuming you have an existing wired HART device, which presumably if you're selling it, you should know what your customer requirements are and how it's used and what applications it's used in, and what the performance requirements of that device might be in real world use cases. How long would it take roughly, if you knew what you wanted from a specification standpoint, to just kind of get to let's just start with getting to a prototype of a wireless HART device. And let's forget about all of the forget about all of the registration and the FCC and all of that sort of stuff. Working with Centero, how long would that take? And what would be the first step that you would undertake with a vendor like that?
Well, as a first step, it would be important to sit down and nail down the requirements of the field instrument, right? Of course, when it comes to developing a wireless HART instrument, you had mentioned earlier, how long would it take to develop a field instrument? It really all depends on your level of expertise, right? As mentioned during the webinar, developing a wireless HART instrument requires a multidisciplinary engineering team. You really need to understand wireless technologies, to have a fairly capable firmware and hardware development team, as well as a software development team for your DD, EDD files. So we've seen field instrument vendors develop instruments by themselves in 4 or 6 months. I would say once you get started, you could probably have an instrument ready to market in about what we see these days, about anywhere from 6 months to a year. And that includes also your passing all the hazardous location tests, which is also very time consuming. But to answer your other question, yes. First, if somebody approached us to help them develop a wireless HART instrument, first of all, we would sit down with them and nail down the application layer requirements of the field instrument. What are you sensing? What are you controlling? How often do you need to burst data? We would sit down and architect the instrument with them and run preliminary calculations on the battery life, see how it meets their requirements. And then we could engage, in some cases, we engage with customers to where we just augment their engineering teams, because a lot of field instrument vendors already have very capable engineering teams. Or in some other cases, we do this as a turnkey project.
Got it. Okay, so let me shoot through some of the questions that are here, and I'll try and one of them is very technical, so I'm going to give you that one first while I can read the rest. Of them. Let's see here. There was one here that I really wanted to start with. Okay, so this is one directly regarding your module, which is, with regards to EXA text, does the Centero module have any internal voltage generating circuits, left parens boost, right parens, and are the bulk L+C published? Does that mean anything to you?
Yes, it does. No, there are no voltage enhancing components, and yes, we do have a fairly detailed analysis document that shows all the capacitances, inductances, everything you need when you would submit your instrument for intrinsic safe compliance.
Okay. Got it.
And if you need that, please contact me. We can share that analysis document with you. But yes, it includes pretty much everything you need in terms of documentation when submitting for, if you decide to get your instrument intrinsically safe certified.
So I wanted to, before I go on to the next question, I wanted to encourage everybody in the audience. We put in the chat, well, we didn't put it in the, well, first of all, we put in the chat a link to our support website. And if your questions don't get answered or you have more detailed questions, please go to the support site, file a ticket. We'll get the question answered. If it happens to go back to Robert, we'll route it to Robert, and we'll get it handled for you. Additionally, when we close down this webinar, your access to the handouts will go away. I mean, we'll post them somewhere else, but if you want to have the handouts now, I encourage you to download them before we conclude the webinar. Okay, so now let me go to some more. Let me go to some more questions here. We had a question about update rates, and this is kind of one of the pet peeves of mine. There was a question about what's the specification required in terms of update rates, and the spec requires something, you know, crazy like 0.1 second. I think we test to 1 second update rates, but frankly, if you're implementing a wireless HART device and battery life is one of the things that you are trying to preserve, it would behoove you to understand from your use cases and your customers, you know, what the real update rates are that they need for their particular application. So I'd say, you know, it's kind of doubtful in a tank level monitoring application where the volume of the tank is going up and down fairly slowly, that you need to update that every second, maybe every minute or every 5 minutes is sufficient. And if so, that has a huge impact on battery life. So Robert, if you want to add to that, go ahead, but I'm going to look for some other questions to answer.
Right, so your burst rate or your update rate, it really depends on obviously on the instrument that you're developing, but what we typically see is anywhere from 500 milliseconds to days, right? So let's say if you're developing well, in some cases we see pressure instruments or even temperature instruments, you know, burst every second or so, or 500 milliseconds. But yes, let's say if you developed a valve positioner, your update rate might be a bit higher than a corrosion monitor that only sends data maybe once an hour or once every 6 hours, right? Corrosion happens very slowly. So yeah, it ranges anywhere, as I said, from the burst rate ranges anywhere from 500 milliseconds to hours, right? Or even days in some cases. And as Paul highlighted or mentioned earlier, your burst rate does have a significant impact on your battery life. As you can imagine, if your battery is going to be, battery life is going to be severely reduced if you're bursting every 500 milliseconds versus every 3 hours. Now, as far as the typical battery lives that we see out there is, we see instruments support battery lives anywhere from 3 to 10 years. There are multiple factors or parameters that influence the battery life. As mentioned earlier, the primary factor is your communication schedule, how often you're bursting messages. There's also, you also have to support bi-directional communications from the gateway. How many alerts or alarms you're sending, how often you're sending these alarms and alerts. In addition to that, the components you choose are obviously very important when it comes to battery, to determine your battery life. What is the sleep mode of the module you're selecting, the wireless module? What is the sleep mode of the application processor you're selecting? When it comes to optimizing battery life, and your target is 10 years, it's an art form, right? Because you have to, put some effort, some elbow grease into optimizing your battery power down to every digital line, the state of every digital line, as well as, waking up, reading your sensors or your actuators, performing whatever computation you need to perform, control the wireless module, put the wireless module to sleep, and so on and so forth.
Okay, thank you. We're going to move on to a couple of different topics. There's some really detailed questions in here, and if you have to leave or we don't get to them, we'll post them into our support site, and we'll make sure that we get answers to you. But I'm going to try and handle a couple simple ones before we dive into another detailed one. One question, it says, so I'm just going to read the question, and it says, so I can develop EDD or FDI and send to registration, or I should mandatorily develop both variants and send to registration. Okay, so first thing is an FDI device package is a package of files. One of the required components of that package is the EDD. So when you submit an FDI device package, you are also submitting an EDD. You really can't submit one or the other. And at this point in time, FDI device packages are required for all registrations. And there's a lot of content on the support site and on our website about FDI device packages. So, okay, let's see here. We have a question here about whether we do all of the tests internally or whether we just look at a report that the supplier sends us. We do all the tests internally, which is frankly why it takes a little bit longer to do some of the WirelessHART registration testing than it does for some of our other protocols because of the necessity also to test not only the HART device itself but also the wireless component. Okay, there's a question here. Is there a new revision of WirelessHART coming soon? Well, the WirelessHART specification is part of the HART specification, and the specifications are always being updated. But I don't think there's a lot of changes that have come into the WirelessHART specification recently. Robert, here's what I'm going to throw to you, which is given, with 5G narrowband and LoRa availability, is this a concern to WirelessHART? You and I discussed this in advance of this, and these are kind of application-specific types of questions. So maybe you could handle that one.
Sure. So let's start with LoRa. LoRa is really a completely different animal than WirelessHART. It really addresses a completely different set of requirements than WirelessHART. It does offer long-range communications, but it does not address low latency, extremely fast publish rates, and so on and so forth. Of course, there are quite a few IoT, technologies out there that are available, and they each meet different requirements. Let's talk about 5G, a bit about 5G, right? 5G is what we've seen in terms of demand. So far, we've seen demand for 5G as being used as a backhaul technology, right? When it comes to battery life, at this point, it'll be a challenge to design a 5G-based field instrument that wouldn't operate, have a 10-year battery life. So yes, there's quite a wide gamut of different wireless technologies and IoT technologies. They're all really designed and architected to meet different goals and different requirements, different use cases. WirelessHART is specifically architected and designed to meet the requirements for process automation, monitoring, and control.
Yeah, and we always get this question: is why is WirelessHART preferred over other technologies? And I think, well, it depends. I'm not going to put a WirelessHART network in to do my home Wi-Fi, but but in process automation, when the data needs to get from the source to the to the destination, and you have a network that is a mesh network that is self-forming, self-healing. So when a drill, when a drill comes in to drill a new hole in an upstream field, and the RF pattern in the facility suddenly changes dramatically, the network is going to automatically route around and repair itself. So if you're interested in something that's very highly reliable and designed for use cases and doesn't require a whole lot of site surveys and constant reconfiguration, WirelessHART is the preferred technology. Okay, a couple more here. A couple of these are really so what's the longest range in meters possible for communication between a device and the gateway in line of sight? And that depends on the antennas, right? But go ahead and give it a shot, Robert.
Well, it depends on the antenna, but it mostly depends on your wireless module, right? And it really depends. So as far as output power is concerned, or if output power is concerned, you have to support plus 10 dBm output, like RF output, right? And so what really comes into play then is the sensitivity of your module, right? How sensitive is your module? Because you can only output 10 dBm. That's the maximum RF power you're allowed to output. So you can only increase your range, line of sight or mesh range, by increasing your sensitivity. Our module supports up to -108 dBm. We put a lot of effort into maximizing the sensitivity of the module to extend the communication range. And I can't speak for other wireless modules out there, but our wireless module has a 2-kilometer line of sight range. Meaning with a 2 dBi antenna, if you place two modules within line of sight, and they both have 2 dBi antennas, we're very proud of our accomplishment, of our engineering feat. We do have up to 2,000 meters line of sight connectivity.
Wow, that's pretty impressive. Okay, we're slowly getting through this. Got that one. I think other than the ones that are really technical, I've got one more, and it's about redundancy. The question is, are there redundant gateways? And some of the gateway suppliers offer a redundant gateway. And the opinion of the WirelessHART Technical Working Group when they developed the standard was that control systems typically know how to do redundancy. So the HART Technical Working Group didn't really feel the need to do it. So so the specification doesn't require it, but there are systems that have been developed that support redundancy. That's the answer to that question. Okay, now there's a question here that I'm going to refer to the text site. There's two of them that I'm going to refer to the text site. One of them is can you tell us how system level test has to be performed for WirelessHART devices, or what is the procedure for getting it from FCG? There are support articles on this topic, and we will direct this question to our support website to answer it. And then there's a very long question here about DDs and EDDs and additional protocol requirements, and I would refer that to, and the question is, if you have an operational HART 7 device in DD, what may be needed to add communication to the WirelessHART module? We kind of discussed this a little bit already in some of the other questions. And is there an overlap between the wired and the wireless DD EDD files? Yeah, absolutely, because it's a HART wired device. It's a HART device, HART application layer device first, but it also needs to support some of the DD requirements for WirelessHART devices. So the answer to that question is yes, but we'll probably also shoot that one over to the support website and give you a more personalized answer to Ed, who asked that question. Okay, we're just about done, and we've only lost a few people since we started this, and we ran about 10 minutes over. So, Robert, do you have any closing comments?
Oh, I'd like to thank all of you for attending and taking the time to attend the webinar. And as mentioned earlier, please do download the handouts, the WirelessHART white paper. We put a lot of effort into that white paper. It's been a work in progress for quite a while now, as Paul knows. And other than that, thank you for attending, and please feel free to contact us if you have any questions, or if you're getting ready to start developing a WirelessHART device. We're here to help, and look forward to working with you.
Okay, and in my closing comment is that, this is the first in 2022 of a series that we call FCG TV here at FieldComm Group. This session is being recorded and it will be made available to you. We have a YouTube channel where a lot of our prior webinars have been posted. Our webinars, sometimes they're focused only on FieldComm Group members. Sometimes they're open to the general public, and in this particular case, we marketed it to the general public. So I assume that some of you that are on here are not FieldComm Group members, but we would certainly like you to be members. We have over 400 members at this point in time, and we like to consider ourselves to be kind of the center of gravity for the process automation marketplace. And if you want to have a voice, as Robert mentioned earlier in the presentation, in future standards development and where the industry is going as all of these various global digitalization initiatives come to fruition, FieldComm Group would be a great place to stay tuned to all of that information and be knowledgeable about it and be able to help your companies with their own product development, product strategy needs to meet your end user requirements. So kind of a long-winded say thank you for joining us on this webinar. And if you're not a member, check out the membership site on our membership section on our webpage. And we will be putting out a schedule sometime soon about our plans for future FCG TV events throughout 2022. And keep an eye out for that email and please register to attend. Thank you very much and have a great day. Bye.